Functions are commands used for defining a variable with a random probabilistic distribution. To define a function, we first need to name it, give the function a name, then define that it's a function, and give two parameters. The A parameter is the function argument. It's always Rn for random. Then the B parameter is the type of function, C for continuous and D for discrete, followed by the quantity of data pairs. If we have 20 data pairs, then it's going to be C or D 20. If it's a continuous distribution with 20 data pairs, then it's going to be C20. If it's a discrete distribution with 24 or 23 data pairs, it's going to be C24 or C23. An example of a function is the exponential and Poisson distribution. These two functions work together. In all the simulation softwares, we use distributions of time. Then we are using only continuous distributions, not discrete. So we're never using a Poisson distribution. We're only using exponential. But if we find that the number of arriving entities per minute behave like a Poisson, then we can be sure that the time between the arrivals of these entities it's going to be exponential. And the way to define an exponential, it's like it is shown in the slide. First, the name, that in this case is XPDIS. We define that it's a function. Random one, this means that for each calculation, we're going to have one variable, and it's a continuous distribution defined by 24 data pairs. We can use it in a way as a generate with a mean of 100, and then we specify that the function is named XPDIS. This is just the name, and the string character over there, the money sign, it's just for defining that the function it's named XPDIS. We can also use it in an advance. There is another distribution that we're going to use, that it's the normal distribution, and we can define it by name it as norm, define that it is a function, also random one. This is that as we already said, that for each calculation we are going to have one variable, and it's also continuous, and at this time we have a definition of 25 data pairs. To use a normal distribution, we need a variable. We need first to name it. In this case, we name it gnorm. We define that it's a variable. We can use f variable or just variable without the f. And then we define that this variable behaves like a function named as norm, the functions that we have already defined, and we then establish first the standard deviation and then the mean or the average of the function. The number sign indicates that the number after this sign is the standard deviation. So 3 in this case is the standard deviation, and after the plus sign it's the mean. In this case we have a normal variable named gnorm with a mean of 15 and a standard deviation of 3, and it behaves like a function named as norm that we have already defined. To use the normal distribution, we use the variable, not the function. In the case of the exponential distribution, we use directly the function. If you see the example right here, we use a generate with a mean of 100 and a function named XPDIS. we use directly the function. And how can we know that we are using the function? Because we establish fn for function, then the name of this function after the string character. In the case of a normal distribution, we don't use the function right away. We use the variable, and then the variable uses the function. So to use it, we can use it in a generate or in an advance. In this case, the name of the variable that we are going to use is gnorm. To establish that we are using a variable, we first define the v before the string character or the money sign, and after this character we use the name. So first v for variable, then the string character, and then the name of the variable. And that variable, it's behaving like a normal function with a mean of 15 and a standard deviation of 3. And this is the way to use the functions in GPSS, the simulation software. I'm going to show you an file where we can see how we can define these functions just in the software. This file is already uploaded in Blackboard, so when you need to use the exponential or normal functions, you just need to download this file and use it in any way you want it. In this case, you are never going to change the definition of the exponential function or the definition of the normal distribution. What you can change is the names of these functions. XPDIS can be named anything else. SNorm for the normal function can also be changed, but never change the arguments for the functions, and never change the data pairs. These data pairs define the exponential behave and the normal behave. What we are going to change is the standard deviation or the mean for any variable that we are using. If we, for example, if we have two normal times in a problem, then we need two variables. For example, we copy this line over here, Control C, then Control V, and we can create another variable with another name, and we just need to add a number right here and change the mean and the standard deviation. And we have another variable. And this is the definition of these functions. To use them, as I already have told you, you can download this file and change it any way you want it. Okay, so this is how to use functions in the GPSS simulation software.